Hi guys, it's Miss Pruitt coming to you with number 3 from our concept worksheet. So we're supposed to sketch a graph only given the characteristics of the graph. A is saying h of negative x equals negative h of x. Hopefully you guys, especially with our conversation that we had today, can recognize what that means. It's trying to tell you that it is an odd function. It is telling you that for every negative x and y value, there is a positive x and negative y value. Odd functions are symmetric about the origin. What that means is for every point, there we go, for every point that I have right there, there would be a separate point right there. In one quadrant, however many I go over and up, it's the same thing here, but I would go over negatively and down in a negative direction. So that's first of all. Next, B, the limit as x approaches, and I know in your paper it came out looking as 0 approaches, or as x approaches 0 from the left. That's actually a plus sign. So I'm going to try to fix that right here. I don't know, the copy machine sometimes, it's not me, it's the way the copies come out. So that actually should have been a plus sign. So it wants to know, okay, it's telling you in this graph, and also, of course, hopefully you can tell that that's infinity. The limit as x approaches 0 from the right, that's what the plus sign means, equals infinity. That means my graph, as we're approaching 0, is going to do something like that, right? I'm not sure about the tail end yet, but I do know that as we get closer and closer to 0, it's going to keep going up. That is telling me that I have an asymptote at x equals 0. All right, what else do I have going on? Looking at C, it says that the limit as x approaches positive infinity, all right, positive infinity, that my function is approaching 0. So that is actually telling me as we go, again, I'm not sure what my graph is doing anyplace else, but I do know that in some way it's going to try to get closer and closer at some point to 0, and it's not going to touch it. This is telling me that I have I need to draw a little more straight, that there is let's use another color so you guys can see, a horizontal asymptote at x equals 0. And not just tells me my end behavior. So there is a horizontal asymptote. Did I say x equals 0, you guys? I meant y equals 0. At y equals 0, we have a horizontal asymptote. Because my function is odd, everything that we do is going to be reflected about the origin. So I want you to keep that in mind. Looking at D, it says for all my positive x values, h of x is going to equal 0 only at x equals 1. This is telling me where my roots are. Remember, roots are the same thing as x-intercepts. I'm going to have a root at x equals 1. But remember, since this is an odd function, not only is it going to be at positive 1, but it's actually also going to be at negative 1. Let me see if I can fit an explanation over here. Plus or minus 1. So remember, for an odd function, for every negative that we put in, the entire thing becomes negative. Or as I showed you at the top, for every negative x, y, there is an x and negative y. So since D is telling us for sure that there is a 1. There's no such thing as -0, you guys. I'm just plugging that in so you can see where I'm getting it from. This is telling me that there's definitely a 1 and a 0, right? So then that means this is an odd function, that -1 and quote-unquote +0 should also exist. And that's where I get that I have a root. A root is an x-intercept. It's also where your y equals 0. At -1 and +1. That's how I got these roots were positive and -1. You really have to pay attention to the fact that this is an odd function. All right, so moving on for E, this is telling me for all of my positive x values, the first derivative equals 0. Remember, anytime you see that the first derivative equals 0, that is talking about a horizontal tangent. A horizontal tangent. And a horizontal tangent means that at some point, I'm either going to have a max or I'm going to have a min. Well, to be most specific, this is telling me that at x equals 2, there is a max or a min. Well, there's actually going to be a min at x equals 2. And because this is an odd function, I'm going to end up having a max at x equals -2. The reason why I'm saying that one is a min and one is a max, and that I can tell, is I already know I have some asymptote information, behavior going on there. And by the way, since this is an odd function, if this is happening on the right-hand side after we're approaching 0, then something along the lines of this is happening on the other side. Also, if I have something going on at x equals 2, there's something going on here that's making this a min. It's because I'm coming down from approaching positive infinity, and I'm going on, actually, because I also have a horizontal asymptote. This point must be a minimum, and if this were its reflection, then at -2, that dude right there should be a maximum. That's where I'm getting that I have a min or a max at +2 and at -2. All right, you guys. So last but not least, at F is telling me that for all of my positive x values, the second derivative is going to be equal to 0 only at x equals 3. Well, if my second derivative is equal to 0, this is talking about points of inflection, where I'm changing from one concavity to another. Since it is happening at x equals 3 for all of my values that are greater than 0, because this is an odd function, it is also going to occur at -3. I'm going to have a point of inflection at -3. So now that we have all this information, let's see if we can go ahead and try to graph this thing. So I'm going to put down what I know. Oh, I know that I have a vertical asymptote. I also know that I have a horizontal asymptote at 0. Remember, you guys can cross. You can cross a horizontal asymptote. The horizontal asymptote mostly has to deal with your end behavior, what's happening on the far ends to the left and the right, or as we're approaching infinity. What else do I know? I also know that there is a root at positive and -1. I also know that I have a minimum at x equals 2. I'm not quite sure where it is, so that's okay. I'm just more concerned about, what the behavior of this graph is going to be. I also have a min there and I have a max here. Just trying to make it a little even. Is that even? A little bit. What else do we know about this graph? I know that I'm going to have a point of inflection at +3 and -3. So let's go ahead and try to bring this all together. I already know that my graph, as it is approaching 0 from the right, is going up to +infinity. So I can even start there. Going from +infinity. I know I have to come down. I have to hit my root. That is my min, so I'm not going any further than that. And at x equals 3, I'm going to hit a point of inflection. So I'm going to change from concave up to concave down. And I'm forever and ever going to try to now get closer and closer to that horizontal asymptote. And it's kind of easy now that we've done that one, that we should be able to then draw the other side of the graph because it's an odd function. It's just going to be like a 180 rotation of the right-hand side. So instead of going to +infinity on this side, we'll be coming from -infinity, going up, hitting our max. At -3, we're changing our concavity from concave down to concave up, and then we're going to try to reach the x-axis forever and ever and ever. And that's how we do number 3.